For those of you that were not loving the quadratics chapter, you can be happy. We're moving on to trig. So the first lesson that we're going to be talking about this week is primary trig ratios. You did go through this in grade 10, so all of this should be review. With that being said, I am going to go back right to the beginning basically, and just start this lesson off complete refresher just so that everyone's on the same page. If when you're doing the questions, you're finding that they're really easy, then that's just great news. Know that we are going to be moving on next week to the sine law and the cosine law, and they will get a little bit trickier. So just make sure that you're really good at your primary trig ratios before moving on. So the first thing that you need to do is make sure that your calculator is in degree mode. So typically this is where I would walk around and help everyone and, fix their calculator for them if they couldn't get it. It's going to be a little bit harder since I'm not physically able to do that. If you can't get it, please let me know and I can try my best to set up a Google Meet with you and we can figure it out that way. So to know if your calculator is in degree mode, you should see a little D at the top or DEG. If it says something else like R or G or RAD or GRAD, that means you're going to get every answer wrong. So you're going to have to find out how to change that. So a couple of ways. Sometimes there's a button that says DRG. You can hit that a couple times until you see the degrees pop up at the top. If you don't see that, you could always look for a reset button on the back that you'd poke in with a little pen. That could be useful too. You could always hit that and it should fix it. If not, you might have to look for your calculator online and try and find the manual. Or like I said, let me know and I can try and help you. The next thing that I wanted to talk to you about is as I'm going through these examples, it's very, very important that you physically have your calculator beside you, the calculator that you're going to be using for this entire unit, and you learn how to do this for your calculator. So what we're going to be typing in will vary depending on calculators. Some you're going to have to hit sine and then the number. Some you're going to have to hit the number and then sign. Some calculators you're going to be adding like an equal sign or an enter in between. So please make sure that you're working through and getting the right answer. If you're not, let me know. Again, I can set up a Google Meet with you. You can join my office hours and we can figure it out together. Primary trigonometric ratios can be used to determine side lengths and angles in right triangles. Which ratio you use depends on what you want to calculate and what you know about the triangle. So the first thing that we need to talk about is that primary trig ratios can only be used for right angle triangles, so only that 90-degree triangle. Labeling the triangle is very important. So the first side that we could label is the hypotenuse. So the hypotenuse is always the angle that is directly across from the right angle. I'll just label this with a full word. You are going to see that typically I do only label it H, but I'm writing hypotenuse for you right now just so that you have it in your notes. Now the next two sides are going to switch depending on what the question is asking for. The most important thing to realize is that whatever angle they give you or whatever angle you're trying to find out needs to be known before you can label the opposite and the adjacent side. In this example, I'm going to be trying to find this blue angle that I've colored in the bottom here. So if this is my angle in question, the side across from it is going to be my opposite side. And the last side obviously is going to be my adjacent. Now you may remember learning about this last year, so you would have probably been taught a fun little word, SOHCAHTOA. And what this helps you remember are the three formulas. So from this so, I can remember that my first formula is sine of theta is equal to, so the S stands for sine, the O stands for opposite, divided by that H stands for hypotenuse. Now from ka, I could see C stands for cos, the A stands for adjacent, and the H stands for hypotenuse. And then from my TOA, the T stands for tan. So tan of theta equals, the O stands for opposite, and the A stands for adjacent. If you're able to remember SOHCAHTOA or SOHCAHTOA, you are able to figure out all three of the formulas that you will need for this chapter. So before moving on to anything crazy, I did want you to get a good feel for your calculator. So I'm going to be asking you just a couple of easy questions, just so that you know the order that you need to plug things into your calculator. So the first thing that we're going to be doing in our calculator is calculating sine of 53. Now some of you are going to have to hit sine and then 53. And then some of you are going to have to hit 53 and then sine. What you do now will help you figure out what to do as we're working through actual examples and problems. You need to be able to do sine of 53 and get an answer of 0.7986. Now your calculator is going to give you way more than that. This is just a rounded version. If you get an error or if you get something else, try the other way. We're going to do another one just to make sure that you know what you're doing. So sine of 90. You should be able to get an answer of 1. Again, some of you are going to have to hit sine and then 90. Some of you are going to have to hit 90 and then sine. The last thing that I want to do is find an angle. So if I were to give you something that says sine of x is equal to 0.1788. I'm asking you to find this angle. We know that if we're trying to find an angle, we have to use sine inverse. Now, when you're trying to figure this out on your calculator, again, some of you are going to be hitting second function sine to get that sine inverse, 0.1788. Some of you are going to be hitting 0.1788 and then second function sine. Either way, you should be able to get an answer of 10 degrees once it's rounded. In the next 3 examples, I'm going to go through the 3 possibilities for you when you're solving these types of questions. You're going to notice that I'm going to be labeling them and working through the problem as well. But if at any time you're stuck, please don't attempt to move on until you can get the right answer on your calculator. So email me, instant message me, set something up, and we'll figure this out together before moving on and getting even more confused. So our first example just says solve for x. So what we're going to do is we need to label our triangle. Since the angle that they gave me is down here and it's 60 degrees, I know that when I'm labeling, the angle or the side across from that is my opposite. Now I know that this side across from my right angle is my hypotenuse. I'm not going to label this side on the bottom because I don't care about it and I don't know it. So I'm not trying to find it and I don't know what it is already, so I'm just not going to label it. When I do this and I only label the sides that I care about, it's easier for me to figure out what formula I want to use. So we can remember SOHCAHTOA. Now I've labeled O and I've labeled H. Right away that I could see that the formula I need to be using is sine. So first things first, I'm going to be writing my formula out. So sine of theta equals opposite over hypotenuse. Next I'm going to be plugging in my information. So sine of, now theta. Theta is just a variable that we're using. It's actually a Greek letter. It's the variable that we use to plug in an angle. You always have to have an angle after a sine, a cos, or a tan. An angle can't just be sitting by itself in the opposite or hypotenuse or adjacent part. So here we're going to have sine of my angle, which was 60, equals opposite, which was x in our case, divided by hypotenuse. Now my hypotenuse was 3.5. Now, what you're going to notice is that now I'm labeling this example as something called x on top. Now I'm calling this an x on top example because you're going to see right here that the value that I'm looking for, or my x, is in the numerator of my fraction or on the top of my fraction. So when I have an x on top like this, I need to get it by itself, but I have this divided by 3.5 in the way. I need to take this divided by 3.5 and move it to the other side. Now we know that when we move things to other sides, we always have to do the opposite. So what I'm actually going to get is 3.5 times sine of 60. Now, sorry, this looks terrible. Now, what you're going to do in your calculator does kind of change a little bit depending on what calculator you have and the order that you needed to do it in the previous slide. So a lot of people are going to hit 3.5 times 60 and then hit their sign button and then hit equals. Other people are going to just type it all in at once, 3.5 sine 60. And then hit equals. I know if you're using your phone, you are probably going to have to do the first way. So 3.5 times 60, and then hit your sign, and then hit equals. Now what you should be getting is x is equal to 3.03. So what this means is that this side length, I'm just going to use yellow right here. This side length right here is equal to 3.03. Now that makes sense. The longest side of the triangle is 3.5, so at least we didn't get a number bigger than that. And 3.03 is not way smaller, so this does make sense for the triangle that we have here. Alright, so example 2, our triangle looks very similar. The only difference is our unknown is now in a different spot. So we're going to go ahead and we're going to label this triangle. First thing I notice, my unknown is across from my right angle. So right away I know my unknown is my H. The angle that I'm given is in this bottom right-hand corner, so I know that this side over here is my opposite. Now, I don't care about that side, so I don't know it and I don't want to know it, so I'm not going to label it. But now that I know that that side would be the opposite, it's easy for me to realize that this side is going to be my adjacent. Now, just like I did in the last example, I'm just writing SOHCAHTOA at the top here so we can see this visually. The sides that I care about are my H and my A. That means that I'm going to be using cos. So I'm going to be writing my formula, cos of theta equals adjacent over hypotenuse. And then my next step is to plug in the information that I know. So I have cos of my angle. My angle is 40 degrees. Is equal to, sorry, I have no idea what's going on with my iPad here, adjacent 5.2 divided by my hypotenuse, which was my x. Now, I called the last example x on top, and if you're thinking ahead, you can probably guess that I'm going to be calling this example x on bottom. For the exact same reasons, when I substitute all of my information into this problem, the variable that I'm looking for is in my denominator. So when I have an x on bottom, I need to swap this side with my variable. So my next line, right away I can just go ahead and I can do that swap. So the x is going to come over here. The 5.2 is going to stay exactly where it is, and the cos 40, the entire thing, not just the 40, the whole left side, cos 40 is going to go here. Now, what you type into your calculator again is going to change based on how you type into your personal calculator. Some of you are going to hit 5.2 divided by 40, hit cos, and then hit equals. Some of you are going to hit 5.2 divided by cos 40 and then hit equals. Either way, you should be getting an answer of 6.79. Please make sure that you're getting 6.79 before you move on. Now, if we're thinking back to our question, we know that this side is 5.2. We know that the side we're looking for is the longest side. The hypotenuse is always the longest. And so an answer of 6.79 absolutely makes sense.